Alright, so the next topic is operations on rational expressions. Now this topic actually is going to take us all of next week as well. So we'll do one page today with simplifying, and then Monday we'll do multiplying, dividing, and then adding and subtracting. Okay, so the first part of it is what are the steps for multiplying and dividing these rational expressions. So remember, rational just means fraction. So we're going to review how to multiply and divide fractions. And then we'll add and subtract fractions. Okay, so this part is just talking about reducing. So how do we reduce fractions? So here, what is this reduced to? Well, we see what we can divide both of them by. We can divide both of them by 2. Not just 2 though, that's not the biggest number we can divide them by. This is 4 times 2. And this one is 4 times 3. So we can divide them both by 4, and we're left with 2 over 3. So whatever's the biggest number you can divide both by is the common factor, and then you reduce. So here, it looks like we can divide them both by 5. So this is 5 times 3, and this is 5 times 11. So we can reduce them both by 5s, and we get 3 over 11. Alright, and then finally this one, looks like we can reduce them both by 7. This one's 7 times 3, and this one's 7 times 4. So if I divide them both by 7, I'm left with 3 over 4. So we can do the same thing with rational expressions. So for rational expressions, we're going to reduce by making sure that the numerator and denominator have no common factors. So that means we cancel out the one that's the same. So cancel out the factors that they have in common. Alright, the important part here is to make sure it's in factored form, which means make sure that they're being multiplied. They have to be multiplied in order for you to cancel them out and say it's A over C. If it's adding or subtracting, you cannot do this. This is not just canceled out and it's 1 over 8. No. You can only cancel out when it's multiplying. So technically this, if I was to give you the fraction, I don't know, 23 over 28, you doing this is the same thing as saying, oh look, there's a 2 and a 2, let me cancel those out, and the answer is 3 over 8. No, we don't reduce that way. We have to put them in multiplied form, which is why we have to do them like this and not like this. Okay, so you cannot reduce when it's adding and subtracting. You can only reduce when it's multiplying and dividing. So that's what we're doing today is reducing. Okay, so for a lot of these, they're going to be quadratics, which means they have x squareds in them. So that means they're going to have some kind of x squared. And we have to remember how to factor those. So remember, there's 4 different ways to factor a quadratic. We can do GCF. We can do difference of squares. We can do the basic, which is where the x comes in. Or we can do AC. So we got to go through these and see which way it factors. So here, looking at the first one, we're trying to factor both the numerator and the denominator. So that's this stuff over here. So if you look at the top part, since there's 3 of them, and the number in front is, there's not a number in front of x squared, we can just do a regular x for this one, and put the 12 at the bottom, and the 7 at the top. So what are the factors of 12 that add to 7? So 12 is 1 and 12, 2 and 6, 3 and 4. So which one of those adds to 7? The plus 3 and the plus 4. So this one is going to be x plus 3, x plus 4. And we do the same thing for the bottom part. Since it's trinomial, and there's not a number in the front, we do an x, with the negative 30 and the minus 7. So 30, 1 and 30, 2 and 15, 3 and 10, 4, no, 5 and 6. So now since it's negative, we want one to be positive, one to be negative. So we want to subtract them to get 7. So when we subtract 3 and 10, we get 7, with the bigger number being the negative one. So this one's a plus 3 and a minus 10. So that's the bottom part. X plus 3 and x minus 10. So we're not done simplifying because we got to cancel out the common factors. But before we start canceling out, I'm going to do this part over here that says state the excluded values. The excluded values are the numbers that make the denominator 0. So that's what x cannot be. So here, what number is going to make this 0 is the opposite of this one. So if I have a plus 3, a minus 3 would make that 0. So negative 3 plus 3 is 0. And remember, we can't divide by 0. And then the opposite of this one, a minus 10 would be a positive 10, because 10 minus 10 again is 0, and I can't divide by 0. Okay, so that's all this part means. State the excluded values is where the denominator is 0. And then you can just divide out any common factors. So the parentheses that's on the top and the bottom is the x plus 3. So this is my reduced answer. My final answer is x plus 4 over x minus 10. So that's what it means to simplify. Just reduce it by canceling out the common factor, but again, you have to factor it first. So set up your x's and cancel out the common one. So that's what we're going to do for example number 2 and 3 at the bottom. Okay, so for example number 2, we want to make our two x's. Since it's a quadratic, it has 3 and there's not a number in the front. We can just set up our x's for this one again. So here for the top, we're going to set up the x, the plus 3 on the bottom, and a minus 4 on the top. So then what are the factors of 3 that add to negative 4? Well, 3 only has one pair, 1 times 3. But in order for us to get a negative 4, they both have to be negatives. So negative and negative makes a positive here. But if I add them together, I just get negative 4. Okay, so the top part factors x minus 1, x minus 3. And then we do the same thing for the bottom. So looking at the bottom one, still trinomial with no number in front, so we still use the x. The 5 goes on the bottom, and the negative 6 goes on the top. So again, 5 only has one pair. 1 times 5 is 5. But to make the negative 6 appear, they both have to be negatives. So then that one we would write as x minus 1, x minus 5, or plus 5, no, minus 5. And then we would divide. So before we start canceling stuff out, let's go ahead and state the excluded values. So this is saying x cannot be, opposite of this one to make it 0 would be positive 1. And the opposite of this one to make it 0 would be positive 5. Again, those are the two numbers that when I plug it in, I get a 0 on the bottom, and I can't divide by 0. Okay, so now they both have x minus 1. So remember, they have to be the same number, same sign. So like if one's a positive and one's a negative, that's not going to work. So since they're both minus signs, they cancel. And this is my simplified form. X minus 3 over x minus 5. Okay, so I think there's only a couple more for simplifying, for reducing. So moving to example number 3 here. So 3 and 4, we're just going to set up a bunch of x's. I'll probably set them up over here and just do them at the same time. Okay, so remember you only factor, so let me write all the ways to factor. When it's a quadratic, that means it has an x squared. And these are the weights. So it's GCF, difference of squares, basic is the x, and AC method is the x with the numbers in the front. Okay, so looking here, this 5 that's in the front doesn't have an x squared, so that's just going to stay 5. This one, however, does have an x squared. So this one, since there's 3 of them, we can actually use basic with the x. So we're going to make an x here. So we put the plus 10 on the bottom and the plus 7 on the top. So what are the factors of 10 that add to 7? Well, 10 is 1 and 10 and 2 and 5. The only one that adds to 7 is the 2 and the 5. So to make a positive 5, they have to be the same. To make a positive 7, they both have to be positives. So for that part, we're going to write it as x plus 2, x plus 5. Okay, divided by, if you look at the bottom part here, this one doesn't have a squared with it. So this one is going to stay x minus 6. There's nothing we can do for that one because it's already factored, it's already linear. The last one, however, is a difference of squares. So remember, difference of squares means it has to be a minus sign, which this one is, minus sign, check. It can't have one in the middle, like it can't have the x squared in the middle. This has to be 0. So technically you could set up an x if you wanted to. You would put the -4 here and the 0 here. So the middle one has to be 0, and this has to be a perfect square, means you can take the square root of it. So remembering how difference of squares factors, difference of squares is always a plus and a minus. So one's positive, one's negative. And the square root of 4 is 2 and 2, but one's a plus and one's a minus. So you take the square root of the number. So here square root of x squared is x and x. So x and x, and then the square root of 4 is 2 and 2. So difference of squares is always a binomial. There's only 2 of them, and they have to be perfect squares with the minus sign. Okay, so now before we start canceling, let's state the excluded values. So this time it's going to have 3. X cannot be opposite of this one. It's positive 6. Opposite of this one is negative 2. And opposite of this one is positive 2. So it can't be those 3 numbers. And then we start canceling out. So the plus 2 cancels out with the plus 2. Anything else? I think that's it. So the rest of it is your simplified form, your reduced form. 5 times x plus 5 over x minus 6 times x minus 2. You don't have to multiply it back out. You can just leave your answer in parentheses in factor form. Okay, so last one for simplifying. I'm going to go ahead and write this part. So if you look at the numerator, 2x doesn't have a thing to factor. So that's going to stay 2x. X plus 5 doesn't have a squared to factor. So that's going to stay x plus 5. The third one is a trinomial, so this one can be factored. So this one we are going to set up an x for it. So we put minus 8 here, plus 2. So what are the factors of 8? We got 1 and 8, 2 and 4. That's it. So the one that's going to give me 2 is the 2 and the 4. But one of them has to be a minus in order for it to be a negative. So how would I subtract these to get positive 2? I would do negative 2 plus 4. The bigger one has to be the positive because this is positive. Okay, so this one is going to factor into x minus 2, x plus 4. Alright, looking at the bottom, this one is a trinomial, so we can set up an x for that one as well. So we have a minus 5 and a plus 4. So 5 only has one factor, 1 and 5. To get a negative, one of these has to be negative. I want the smaller one to be negative so that the bigger one takes this sign up here. The bigger one's the positive. So for that part, we leave x minus 1, x plus 5 for these two numbers. And then I also have this minus 2 here. So this one doesn't have a squared, so it's just going to stay x minus 2. And then you can state the excluded values and start canceling. So x cannot be. Opposite would be positive 1. Here, negative 5. And then here, positive 2. So once you state them, then you can cancel the x plus 5, cancel with the x plus 5, x minus 2, cancel with the x minus 2. Anything else? That's it. So 2x stays, and x plus 4 in the numerator. And then in the denominator, just this x minus 1. If by chance everything happens to cancel out, like on the top or on the bottom, then you're left with 1. So for example, if this one canceled out with this one up here, then nothing would be left on the bottom. Technically there's a 1 there, but you don't have to write it. If it's on the top, you do have to write it. I think we're going to see some of those next time when we multiply. Okay, so that's reducing and simplifying.